This is Catherine Schmur at Chattanooga State Community College, and this is video 2 of Lines in Space. In this video, we'll talk about the parametric equations of a line. In video 1, we talked about vector equations of a line. The parametric equation of the line through the point P0, defined as x0, y0, z0, and parallel to vector v equal to v1i plus v2j plus v3k is x equals x0 plus tv1, y equals y0 plus tv2, and z equals z0 plus tv3. So that set of three equations, x equals, y equals, z equals, is our parametric equation of the line. So here's our example. We want to find the standard parametric equations for the line that passes through the point 3, negative 5, 2, and is parallel to the vector j minus 3k. So this point is x0, y0, z0. So I know my values that I'm going to have for x0, y0, and z0. 3, negative 5, 2. This vector is the direction vector. J minus 3k gives me the vector 0, 1, negative 3. There's no I component written, and that's why the x component is 0. So now the equation of my line is going to be x equals 3, because it's like 3 plus 0t. Y equals negative 5 plus t, because I have y0 equal to negative 5 and the j component equal to 1j. And z equals 2 minus 3t, because my z0 is 2 and my k component has a negative 3. So these are the parametric equations of the line. To find points on the line, I would just pick different values for t and plug them in, and that would give me a bunch of points on the line. Now this practice problem is usually something I have students work on in class. So if you want to pause the video and try it on your own before we go over it, that would be a good thing to do. A line passes through the points P, 1, negative 1, 7, and Q, 3, negative 2, 8. Find the standard parametric equations for the line using the base point P, 1, negative 1, 7, and the components of the vector PQ. So this is just like the last example we did, except we have to find the vector first. So PQ equals terminal point minus initial point. So all of my Q values minus my P values. So 3 minus 1, negative 2 minus negative 1, and 8 minus 7. This gives me 2, negative 1, 1. So there's my direction vector for the line. So that's V1, V2, and V3. Now the line is going to be x equals the x component of P plus V1 times my parameter t. So that would give me x equals 1 plus 2t. Y equals the y component of P plus V2 times t. So that gives me y equals negative 1 minus t. And then same for z. Z equals 7 plus t. So there's the equation of the line. So remember, anytime you're asked for a parametric equation for a line, you're going to take the point, and that'll just be by itself, and then you'll take your direction vector and attach the parameter t to it. so the direction vector attached to t, or whatever parameter you're using. And those are parametric equations for a line. Again, to find points on the line, just pick values for t and plug them in.